Hello everyone, welcome back, week 3 of Baycroft Learn. We're going to dive straight into it today, but firstly my apologies if I start coughing or spluttering or anything like that, you're going to have to bear with me. Quite a lot to cover today, but what I think are some fairly quick wins. In other words, there's a bit of this which isn't too complicated, we just need to remember what we have to do. We're going to dive straight in, so we're going to be looking at fractions over the course of the next couple of weeks, because this is a biggie, this is an important one, not just because of your GCSEs, but also it's a real life skill. Excuse me. We're going to be looking at simplifying, adding, subtracting, multiplying and dividing fractions. So firstly, simplifying. Something that we've recovered in a previous one of these, but in relation to something different. I think it was in relation to ratio. Simplifying fractions is a really important thing because quite often in your GCSE they will ask you to work out something and then give it in its simplest possible terms. So it's worth revising
What's it worth doing?
It's worth revising what we mean by simplifying. So simplifying is just saying the same thing but in the smallest possible numbers. And there's a process that we follow. So for example, if we've got a fraction of 12 over 16, the method that I always tell you is start with 2, then look at 3, then look at 5. These two doesn't really matter what order they come in. For the majority of these kind of questions, that will work, okay? But what do we mean by that? Basically, what we want to do, as I say, is express this in the smallest possible numbers. So we can divide the top number and the bottom number to come up with smaller numbers. If both of the numbers are even, we can always use our 2 times tables. Okay, so let's divide 12 by 2. How many 2's are there in 12? 2, 4, 6, 8, 10, 12. Okay, so we've got 6. What we divide the top by, we have to divide the bottom by. So how many 2's are there in 16? There are 8. Okay, so we're done, except we're not, because we can go again, okay? We can still divide the top and the bottom numbers. So 6, again, is an even number, as is 8, so we can divide by 2. So 6 divided by 2 will give us 3, 8 divided by 2 will give us 4. Now we can't go any further. So this is saying the same as that, but in much smaller numbers. Okay, and that's what we do when we're simplifying. Now, as I said previously, if your times table knowledge is really good, you might be able to skip some of these steps, but actually, if we work by dividing by 2, 3 and 5, most of the time we will get there. I've got another example. I do write these down so that I don't get confused. Okay, got another example here of 18 over 27. Now, in this case, the numbers aren't both even, so we can't use our 2 times tables, okay? Can we use our 3 times tables though? Yes, we can, okay? I would like you to now simplify that using your 3 times tables. Cool, okay, that's simplifying. I'm not going to go on about it because it's something we've covered a lot, but it's worth reminding ourselves because, as I say, it's an important one. Now, when we're talking about operations normally, we love adding and taking away, they're the easiest ones. Then multiplying, we don't like dividing. When it comes to fractions, actually, multiplying fractions is the easiest one, okay? So I've got an example which I've written down here. I'm only going to do one because it really is easy. 2 over 5 multiplied by 5 over 6. Yuck, looks horrible. It's not. We really do just multiply the top by the top and the bottom by the bottom. Now, something that I should have said is just to remind ourselves about the names of those, because that's going to be important in a moment. The top number is the numerator, the bottom number is the denominator. Okay? So we're going to multiply the numerator, so 2 times 5 will give us 10. Then we multiply the denominators. 5 times 6 will give us 30. Okay? We can simplify that. We can express that same answer but in lower numbers. I'm going to leave you to do that for yourselves. Dividing. Now, division, generally speaking, is our least favourite of our 4 operations, okay? But actually, with fractions, we can make it easy as long as we remember the rule, which is keep, change, flip. Okay? What do we mean by that? Well, and Mr. Mitchell, please tell me if at any point I go off the camera. I'm sure that would be an absolute disaster. 4/5. Okay, what do we mean? Keep. We keep this as it currently is. So we're going to keep 2/7. We change. We're going to change our divide into multiply. And then we flip. We are going to flip this on its head. So the denominator now becomes the numerator, and the numerator now becomes the denominator. We multiply it out, and that gives us our answer. Okay? So division, actually we can make dead easy by not working with division at all. We can turn it into multiplying. Okay? Let's do an example. I'm not going to go through that one just because I haven't really got the room. So, let's do another example. Let's do 4/9 divided by 2/3. What was the rule? The rule was keep, change, flip. We keep the first one, we change this to times, and we flip this one. Now we just multiply. 4 times 3 is going to give us 12. 9 times 2 is going to give us 18. And now we simplify. Okay? They're both even numbers, so we can use our 2 times tables to simplify this down. Which I'm going to leave you, no, in fact, let's do this one. 12 divided by 2 will give us 6. 18 divided by 2 will give us 9. We can't use the 2 times table anymore because we've got an odd number, but we can simplify further. We can use the 3 times table, okay? 6 divided by 3 will give us 2, 9 divided by 3 will give us 3, okay? Good enough so far, sir?
Perfect, very good.
Cool. Right, adding. The first part of adding fractions is really, really easy, but again, there's an important thing that we have to remember. So, let me have a look for my adding examples. 2/5 add 1/5 equals. In the case of adding, for the reasons that we've gone through before, we add the numerators, the denominator stays the same. Okay? So 2 plus 1 will give us 3, and the denominator stays exactly as it currently is. Okay? Same for taking away. Let's use exactly the same example. 2/5, but this time we're going to take away a 1/5. Well, 2 take away 1 leaves us with 1, and it's going to be 1/5. Okay? So when we are adding and subtracting when the denominators are the same, we just add or subtract the numerator, keep the denominator the same. But it does get a little bit more complicated when the denominators are not the same. When we are adding and subtracting fractions with different denominators, we have to use our lowest common multiple skills in order to make the denominators the same. Now, we looked at lowest common multiples just yesterday and you made fantastic progress. So we know what we need to do here. We need to list out our 6 and our 5 times tables in order to find the first number that appears in both lists. We can then use that as our denominator, okay? So let's have a look at what that actually means. So let's start by finding our lowest common multiple. So 6, 12, 18, 24, 5, 10, 15, 20. What's the smallest number that appears in both lists? There isn't one. So we're going to write out a few more. 6, 12, 18, 24, 30, 36, 20, 25, 30. So we've now found the first number that appears in both lists, which is 30. And we can use that as our lowest common denominator. Common, of course, meaning the same. Okay? So, or in this instance, common means the same. So, whatever we've done to the bottom, we then have to do to the top. So, we know that we can use 30 as our common denominator, but we've changed 6 into 30. How have we done that? We've multiplied it by 1, 2, 3, 4, 5. which means we have to times the top by 5. So 1 times 5 is going to give us 5. We've also changed our 5 into 30 by multiplying it by 1, 2, 3, 4, 5, 6, which means we have to change, times the top by 6, which will give us 12. Now we can work with it because our denominators are the same. Then we're simply going to add, which will give us 17 over 30. Okay? I'm going to do one more example of that because this is a little bit of a tricky one. So, let's have a look at 4/5 take away 1/3. At the moment, we can't work with it. The denominators are different. So how do we find a denominator we can work with? We use our lowest common multiple. We start by listing them out. 5, 10, 15, 20, 3, 6, 9, 12, 15. So there we go. We've already found our lowest common multiple, which means we can use that as a denominator. Okay? So we're going to rewrite this question, but with both fractions over 15. But what have we done in order to turn that 5 into 15? We've times it by 1, 2, 3. Okay, which means we have to times the top by 3. So 4 times 3 will give us 12. What have we done to the 3 to turn it into 15? We've times it by 1, 2, 3, 4, 5. Which means we have to times the top by 5. And now we can work with it. Okay? 12 take away 5 will give us 7 over 15. I'm just looking to Mr. Mitchell for some reassurance because I'm not feeling too great at the moment. How did that look, sir?
Superb. All good.
All making sense? Great. We are going to do what we've done this week, which is on Thursday, we are going to cover this again in the lesson with some slightly more complex questions. Okay? Cool. Have a good weekend.